NENOMATICA, where mathematics meets YouTube excellence. Welcome to this mathematics lesson, where we'll learn about dividing algebraic expressions. When we divide one algebraic expression by another, we need to follow certain rules and manipulate the numerical coefficients and corresponding variables appropriately. To divide one algebraic expression A by another expression B, we need to manipulate the numerical coefficients and corresponding variables following the rules of exponents. Let's look at our first example. We need to simplify the expression a squared be divided by c multiplied by c squared be divided by a squared. First, we'll rewrite this as a single fraction. When multiplying fractions, we multiply the numerators together and the denominators together. Next, we multiply the terms in the numerator and denominator. In the numerator, we have a squared b times c squared b, which gives us a squared times b times c squared times b. In the denominator, we have c times a squared. Now, we'll rearrange the terms to see what can be simplified. In the numerator, we have a squared times b times c squared. In the denominator, we have c times a squared. Now, we can cancel out the common factors in the numerator and denominator. We have a squared in both the numerator and denominator, so those cancel out. We also have c in the denominator, which can be cancelled with part of c squared in the numerator, leaving us with just c. After simplifying, we're left with b squared times c. Since this is divided by 1, our final answer is b squared c. Let's look at another example. We need to simplify the expression. A divided by 2b multiplied by 3b divided by 2, a squared, multiplied by 4 divided by a. Let's start by combining all fractions into a single fraction. We multiply all numerators together and all denominators together. Now, let's multiply the terms in the numerator and denominator separately. In the numerator, we have a times 3b times 4, which equals 12ab. In the denominator, we have 2b times 2, a squared times, which gives us 4ba cubed. Now, let's rearrange the terms to better see what can be simplified. In the numerator, we have 12 times a times b. In the denominator, we have 4 times b times a cubed. We can cancel out 1a and 1b from both the numerator and denominator. After cancellation, we're left with 12 divided by 4 times a squared in the denominator. We can simplify 12 divided by 4 to get 3. So, the final simplified expression is 3 divided by a squared. To summarize, when dividing algebraic expressions, we 1. Rewrite the expression as a single fraction. 2. Multiply the terms in the numerator and denominator. 3. Cancel out common factors. 4. Simplify the resulting expression. Practice these steps with more examples to become comfortable with this process. To simplify this fraction, we'll use the properties of fractions and exponents. Let's first break down the numerator and denominator into their factors. First, let's simplify the constant terms. We have 2 in the numerator and 4 in the denominator. We know that 2 divided by 4 equals 1/2. Now, let's handle the variable terms. For the variable a, we have a squared in the numerator and a to the first power in the denominator. Using the exponent division rule, when we divide a squared by a, we get a to the power of 2 minus 1, which is a. Similarly, for x, we have x cubed in the numerator and x squared in the denominator. Using the same exponent rule, we get x to the power of 3 minus 2, which is x. Now that we've simplified all terms, our final answer for the first example is 1/2 times a times x, which can be written as a x over 2. Now, let's move on to our second example. Similar to our first example, we'll break down the numerator and denominator into their factors. Let's start by simplifying the constants. We have 24 in the numerator and 4 in the denominator. We can divide both by their greatest common divisor, which is 4. 24 divided by 4 equals 6. Now, for the variables. For x, we have x squared in the numerator and x to the first power in the denominator. Using the exponent division rule, we get x to the power of 2 minus 1, which is x. For y, we have y squared in both the numerator and denominator. When we divide y squared by y squared, we get y to the power of 2 minus 2, which is y to the power of 0, or simply 1. So, our final answer for the second example is simply 6x. y to the power of 0, or simply 1. So, our final answer for the second example is simply 6x. Welcome to our video on simplifying algebraic expressions and working with exponent laws. In this video, we'll look at several examples to help you understand how to simplify complex algebraic fractions using exponent properties and fraction operations. Let's start with our first example. We need to simplify the expression 14, a squared b divided by 7ab. To solve this, we'll try to separate the numerical coefficients from the variables and then simplify each part separately. First, let's rewrite this as a product of fractions. We get 14 over 7 times a squared over a times b over b. Now, we simplify each fraction. 14 divided by 7 equals 2. A squared divided by a equals a. And b divided by b equals 1. Multiplying these results together, we get 2 times a times 1, which equals 2a. This is our simplified answer. We can check our answer by plugging the original values back in. If I substitute a equals 3 and b equals 4 into both expressions, they should evaluate to the same value. Now let's move on to our second example, which involves square roots. We need to simplify the square root of 6x to the fourth power y cubed z divided by the square root of 2x squared z. The first thing to remember is that we can break down the square roots into separate terms. So we have the square root of 6 divided by the square root of 2 multiplied by the square root of x to the fourth over x squared, multiplied by the square root of y cubed divided by the square root of z squared, all times the square root of z. Now we can simplify each term. For the first term, the square root of 6 divided by the square root of 2 equals the square root of 3. For the second term, the square root of x to the fourth is x squared, and this divided by the square root of x squared, which is x, gives us x. The square root of y cubed equals y to the 3/2 power, or we can write it as y times the square root of y. Finally, the square root of z divided by z is 1 over the square root of z. Combining all these terms, we get the square root of 3 times x times y times the square root of y, all divided by the square root of z. This can be written as x times the square root of 3, y divided by the square root of z, or simpler still, as the square root of 3 times x squared times y cubed. Let's move on to our third example. Here we need to simplify 18 a squared b cubed c to the fourth power divided by 6 ab cubed c squared. Let's rewrite this as a fraction and then simplify each term. We get 18 divided by 6 times a squared divided by a times b cubed divided by b cubed times c to the fourth divided by c squared. Now, we simplify these terms. 18 divided by 6 equals 3. A squared divided by a equals a. B cubed divided by b cubed equals 1. And c to the fourth divided by c squared equals c squared. Multiplying these all together, we get 3 times a times 1 times c squared, which equals 3ac squared. Let's look at our fourth example. We need to simplify to a to the 7th power b to the 5th power, divided by 5b cubed a to the 4th power. Let's rewrite this as a fraction. Now we'll rearrange as fractions of like terms. We get 2 divided by 5 times a to the 7th divided by a to the 4th times b to the 5th divided by b cubed. When we simplify, we get 2 over 5 times a to the exponent 7 minus 4, which is a cubed, times b to the exponent 5 minus 3, which is b squared. So our final answer is 2/5 a cubed b squared. Let's tackle our final and most complex example. Here we have 48 a to the 20th power b to the 30th power c to the 40th power divided by negative 12 a to the 15th power b to the 25th power c to the 35th power. Let's rewrite this as a fraction. Now, we simplify each part separately. For the coefficients, we have 48 divided by negative 12, which equals negative 4. For the variable a, we have a to the 20th power divided by a to the 15th power, which equals a to the exponent 20 minus 15, which is a to the 5th power. Similarly, for b, we have b to the 30th power divided by b to the 25th power, which equals b to the 5th power. And finally, for c, we have c to the 40th power divided by c to the 35th power, which equals c to the 5th power. Bringing it all together, our final answer is negative 4a to the 5th power b to the 5th power c to the 5th power, which we can also write as negative 4a to the 5th power b to the 5th power c to the 5th power. We're given three expressions. A equals 6x squared y cubed z raised to power 4. B equals 4x raised to power 4 y cubed z squared. And C equals 12x squared y squared z squared. We need to calculate the value of a times 2b divided by c. Our first step is to substitute the values of a, b, and c into our expression. Let's substitute a equals 6x squared y cubed z to the power 4, multiply it by 2 times b, which is 2 times 4x to the power 4 y cubed z squared, and divide all this by c, which is 12x squared y squared z squared. Now, let's simplify the numerator by multiplying all the terms. 6x squared y cubed z to the 4th times 2 times 4x to the 4th y cubed z squared. This gives us 48x to the 6th, y to the 6th, z to the 6th in the numerator. Finally, we simplify the entire fraction by dividing the numerator and denominator. We divide 48x to the 6th, y to the 6th, z to the 6th by 12x squared y squared z squared. First, let's divide the coefficients. 48 divided by 12 equals 4. Next, for the variables x to the 6th divided by x squared gives us x to the 4th. Y to the 6th divided by y squared gives us y to the 4th. And z to the 6th divided by z squared gives us z to the 4th. So our final answer is 4x to the 4th y to the 4th z to the 4th. Let's look at our example. If we have a equals 3a squared b to the 4th power and b equals 5a cubed b to the 6th power, we need to find the value of the following expression, a cubed minus b squared, all raised to the 5th power. Let's solve this step by step. First, we'll substitute the given expressions for a and b into our main formula. We have a cubed, which is 3a squared b to the 4th, all cubed, minus b squared, which is 5a cubed b to the 6th, all squared. And then the entire expression is raised to the 5th power. Next, we'll simplify by applying the power of a power rule, which states that when raising a power to another power, we multiply the exponents. For a cubed, we get 3 cubed times a to the 2 times 3 power times b to the 4 times 3 power. Simplifying, we get 27a to the 6th power, b to the 12th power. For b squared, we get 5 squared times a to the 3 times 2 power times b to the 6 times 2 power. Simplifying, we get 25a to the 6th power, b to the 12th power. Now, let's subtract these terms. Since they have the same variables with the same exponents, we can combine like terms by subtracting the coefficients. 27 minus 25 gives us 2, so we have 2a to the 6th power, b to the 12th power, all raised to the 5th power. Finally, we'll apply the power of a power rule one more time to raise our expression to the 5th power. This gives us 2 to the 5th power times a to the 6 times 5 power times b to the 12 times 5 power. Computing the powers, 2 to the 5th power is 32. 6 times 5 is 30, so we have a to the 30th power. 12 times 5 is 60, so we have b to the 60th power. Therefore, our final answer is 32a to the 30th power b to the 60th power. Let's 30th power b to the 60th power. Let's recap what we've done. We started with the expression a cubed minus b squared. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.